say, oh, well, they're not telling the pilots what those are.
All right,
now
we're going to
that
go
they've
live.
declassified them,
We're going to go live now. So, yeah. Yeah, no, I mean, absolutely. Like the certainty that it is aliens, like even if it is a weird spacecraft that nobody knows what it is, or a weird aircraft that nobody knows what it is, that doesn't mean it's aliens. It just means, I feel like there's a term that's already been figured out for this that includes unidentified and flying an object in it.
They have confirmed it's that, though.
Too. We'll talk about this, and someone will say, so do you think there's life in the universe? Well, we know there's lots of planets, lots of potentially habitable things. Sure, I think there's a good chance. So you're saying aliens visit Earth? No.
I don't say that.
Yeah. Saying there are microbes light years away is not the same thing that they built spaceships and visited.
Yeah.
Well, now with the ubiquity of drones, I mean, those do all kinds of stuff that, 30 years ago you say, well, a plane can't do that. Well, yeah, but now, a drone could be any shape and can really whiz around really quickly.
Yep.
Yeah, I saw just now I think the Air Force is buying a drone that looks like a bird.
Wow. You got to check out this Twitter feed. Birds aren't real.
Yes.
Conspiracy theory. They say,
I'm glad there's
they're telling us all to stay inside because they're changing the batteries on the birds.
I'm really worried that that's going to be like the flat Earth, and more people.
Right, more and more people are going to believe that. Yeah, watch out when you create a hilarious troll conspiracy theory. When you find out how many people actually will sign up for it.
Yeah. On Reddit, there's one of Earth doesn't exist.
Whoa.
It's just they've taken it. It's a parody, but take it past the flat Earth and go, the Earth doesn't even exist.
All right, everybody, say hi to me. Now's your chance. I'm going to say hi back to Adam Synergy, Brexit Denier, David Dunn, David Fairweather, Horizon Brave, John Musk, Johnny J, Larry Beckham, Luke Duke, Miss Scooper, Nancy Graziano, Paranor, Rich Wilson, Arjone, Sergusi, Susie Murph, Tony Flush, and I'm sure some other people. Nico Girl, Arjone, Miss Scooper, Sergusi, Larry Beckham, Powell Zersky, Eric Schneider. Hey, everybody. Welcome. We will get started in just a couple of minutes. I hope everybody is staying safe and relatively sane in whatever COVID hotspot you're currently enjoying. You're in the heart of it, Alex, right? You're in New York.
Right. I'm here in Manhattan. Mm-hmm. Yeah. Well, we're flattening the curve. Things are looking positive. We're not out of the woods yet, but it's pretty quiet. I'm up here by Columbia University, so the students have cleaned out, and at nighttime especially, it's really a ghost town. But I don't know. The weather's getting really nice. There was a lot of people out yesterday, so it's going to be harder to everybody keep their distance once the weather gets really nice.
Yeah, I mean, it's still really hard to sort of see news. I've seen on one report, they were saying like from Wuhan that the number of people who had actually contracted the disease from outside was just a handful compared to everybody else was inside, sharing air in restaurants, in schools, workplaces, things like that. So that's a positive sign because, I mean, if we can go outside during this time, that would be great.
Yeah. Well, you got to get some sunshine. You got to get some exercise.
Yeah.
As long as you're keeping your distance.
Yeah, exactly.
I don't know. What do I know? I'm not a.
No, and I think that's
I'm not going to armchair.
Yeah, that's the biggest thing that we saw, right? Was like, let's not be armchair epidemiologists. We'll let them do that job.
Right.
As my niece once said, about me, I am a doctor, but I can't do anything for you.
unless the question is you need somebody to calculate some astrophysical number. If your life depends on calculating the Schwarzschild
aliens come and say you must calculate this or the world is destroyed.
Right.
I'm useful.
I could. Yeah, that's right. Or on an airplane, right? Is anyone a doctor?
Right.
Yeah. That would help.
Yeah.
All right. Well, I think we can shift over to the actual show now. So let me put you all back into your boxes. And we'll go to me. Here's me. All right. Here we go. Hello and welcome to the Weekly Space Hangout for Wednesday, April 29th, 2020. I'm Fraser Kane, publisher of Universe Today. This week, we're going to be talking about how you might weigh the universe. Starlink is going to be their specific plans for making those satellites a little darker. The 100th anniversary of the Great Debate. Now the question is there life in the universe? An asteroid zipping past the Earth. Did Pluto harbor an ancient ocean? And if we have time, we're going to show a supermassive black hole orbiting another supermassive black hole. So joining me this week on my screen, I've got Dr. Brian Koberlein. Brian.
Hi, everybody. It's good to be here.
We've got, let's see, Alex Tichy. Alex, welcome back.
Hi, Fraser. Thanks very much. Good to be here.
I've been counting. I think this is your third one. You're now a veteran. So
I guess so.
Yeah. We've got Dave Dickinson. David.
Hey, I'm growing out my pandemic ponytail for 2020 here. So
that's good. Yeah.
It's like week 8, 9. I'm losing track.
Yeah.
So.
At some point, you're not going to take the risk and let your wife operate.
Oh, we'll see. We're on lockdown till June 10th at least.
Yeah.
So it's another month and a half still here in Virginia anyway. So
yeah.
we went on lockdown early too. So.
Yeah. All right. So before we get on to our special guest, I just want to give a big thank you to, of course, our good friends of the Weekly Space Hangout crew. They are our friends, our fans. They are the executive producers of the show. As always, you can really thank the existence of our guest on this show to the Weekly Space Hangout crew, specifically Nancy Graziano, of course. So, but if you want to be a part of that incredible group, go to wshcrew.space, sign up. They will embrace you with open arms and give you your executive producer business cards, which will then let you bring on all the guests that you want. Go talk to astronauts, astronomers, bring them on the show. It's up to you. I just interview them. All right. Speaking of people that I interview, we've got Chris Carberry. Chris, welcome to the Weekly Space Hangout.
Oh, great having me on. Thank you, and I'm glad to be on tonight. How are you doing?
Good. And I know we sort of went back and forth and tried to figure out a way to properly present the important news that you have to bring us. And this is the format. Chris, who are you? What do you do? And also, when can I drink alcohol in space?
Well, my name is Chris Carberry, as you mentioned. I'm the CEO of Explore Mars. But I'm also the president of a new group that we're just founding called the Space Drinks Association, which it was actually slowed down a bit because of the current COVID-19 crisis. We were going to announce it like a month ago, but everything got slowed down. But this is a group of different groups around the world that are actually looking at this, which comes back to my book. As you mentioned, when will you be able to drink alcohol in space? And that was the whole focus of the book. And actually, probably sooner than you may think. There are dozens of companies and organizations around the world that are actually looking at whether you can manufacture and consume alcohol in space.
Yeah.
So,
you had Andy Weir actually do the introduction to your book, which I thought was great, considering the fact that that his main character had a lot of potatoes to work with, and apparently, I like the math that he did. That apparently, if he took all his potatoes, he would have to consume or destroy a month's worth of potatoes for a bottle of vodka if that's the path that he wanted to go. So it, probably not that efficient, even though it would be fun.
That's true. If Mark Watney had actually decided to make vodka, he would have died 3 months before he was able to get picked up by his crew. It probably wouldn't have been a wise usage of the potatoes, but it was a valid usage, meaning Andy did a lot of great research, and a lot of scientists do believe we can grow potatoes on Mars. There's actually a NASA group called Potatoes on Mars, examining different types of potatoes that grow in, extreme environments and how close they can get them to the Martian environment. They'll never likely be able to grow them in the, right out in the open, but they're just seeing how extreme they can get so they can grow potatoes or other crops in extreme environments and also save energy at the same time. And so they don't have to have the same atmosphere as for humans.
So let's talk a bit about just about Explore Mars first. So tell us about this organization.
Well, Explore Mars is 10 years old this year. We just hit our 10th anniversary in February. And we're kind of different than other space advocacy groups. We're not a membership group, but we run programming, do policy work. We have tried some technical projects, but what we do best is bringing different groups together, different organizations that may not necessarily see eye to eye, and find the way to connect them, try to build the overall space community. I think we've done that very effectively over the past 10 years. Some of the programs we do are the Humans to Mars Summit, which is the largest annual conference in the world focused on sending humans to Mars. We also run these workshops with stakeholders called the Mars Achievability Workshops, which essentially brings the stakeholders together to figure out what the most sustainable path is for getting to Mars. And we've recently brought the lunar community in also to show how, if we go to the moon, how can we utilize the moon to feed forward to get to Mars and do it in a way that's not going to delay Mars by 20 or 30 years.
And where do you think we are on that? Because people always want, I know that the right way to do it, people have flip-flopped back and forth. Do we go to the moon first, use that as a jumping off point to go to Mars? Bob Zubrin, of course, would like us to just go directly to Mars. Where do you land on that spectrum?
I land on the way that's going to be most politically realistic to do it. And this is where, and I respect Bob Zubrin. I used to work for Bob Zubrin. I was the executive director of the Mars Society prior to founding Explore Mars. But right now, I think if we can find the right way that is not only fiscally, that it's affordable, but also politically realistic. And so those two things aren't necessarily the same. The most efficient plan isn't necessarily the most realistic plan. So it's finding the balance between all these different forces and creating a viable plan and trying to get there by the 2030s. So everybody says, do you think SpaceX will beat NASA? Do you think, another country will? I don't know. Actually, I think it's going to be combined effort, finding the right balance between all of these players to get it done. So I don't necessarily root for any particular angle, but just keep trying to push what is likely to be, the most likely path forward.
But part of the problem, I think, is that there's this fundamental misunderstanding about how expensive an undertaking going to Mars is and how essentially little financial money we will see, how much money we're going to see in return. There's no return on investment, no direct return on investment. I mean, there's going to be new incredible developments in technology that we will see all of these repercussions in our society. And it's wonderful to have this goal for us to rally around as the next logical place for humanity to set its sights. I mean, these are all really valuable, but it's going to be a place that people are going to be setting money on fire for a long time.
This is true. There isn't a business model for going to Mars quite yet. Even Elon will concede he's not going to make any money going to Mars. This is purely being done out of passion. However, it is blown out of proportion how much it's going to be cost. We've all heard what we call the great $1 trillion myth. A lot of folks, basically people who oppose it, say, it's going to cost $1 trillion. And it's not going to cost, any program, any federal program or any program, if you go long enough, it's eventually going to cost $1 trillion. NASA, with all budgets combined, even with adjusted dollars, isn't close to $1 trillion. And so even with, all the plans I've seen, if you do not even conservative estimation, just looking at what the top level will probably be, it's still not close to that. And it's not much more than what NASA already gets. And if we combine in the partnerships with new commercial players and others and internationals, I think we can find the right balance without major increases in NASA's budget. So I think this is a great investment. So we're not going to get money back directly. That's not the nature of this kind of program. But as you mentioned, the benefits in technology, just inspiration, STEM education, but also the diplomatic power of it. People look, even now, even if people don't like our policy on everything under the sun, everybody looks to us for leadership in space. And I feel that the space program and going to Mars It's one of the greatest diplomatic tools the United States has.
Right.
And so I think there's so many different ways of looking at it that are beneficial, reasons to go. Plus, it's probably one of only one or two things right now that have strong bipartisan support. Not many of those exist right now. So
yeah, it's funny to see people who would necessarily be on opposite sides of the political spectrum absolutely agree on STEM and space exploration. Of all of the fields, I actually find we have to deal with politics almost the least amount here in this field, which is great. But I mean, I think that for a lot of people, they're imagining a bustling city on Mars or on the moon. But is Antarctica a better model for what we can expect to see in the foreseeable future?
Early on, yeah. Antarctica is probably the most realistic model we have for early Mars settlements. I think it's a good model. We have to, I love that people have these ambitious goals of getting 1 million people to Mars. It's not just Elon. The UAE has their 100-year Mars, Mars City program. They want to have a Mars City by 2117, I think it is. And that's well and good. We may do that. But first, we have to find out if we can actually live on Mars.
Yeah.
We think we can, but we're not sure about that. There's a lot of speculation. There are toxins, perchlorates in the soil. We think we know how to deal with them, but there's a lot of it. And so even if we can extract that from the soil, it's going to be a lot of it in the environment. And there are probably a lot of other factors we're not sure about.
Yeah.
Of course, we've never had experience with humans living in 1/3 gravity.
Right.
As well. So there are a lot of factors that we think we're going to be able to deal with, but we don't know for sure. So it would be good to have that initial phase, similar to an Arctic base, to just see if we can live there, but also if we can live off the land and we can grow crops, etc.
Right. All right. Well, let's segue then into a very important crop, which is whatever will help us make beer.
Well, it's an interesting one because there's been a lot of thought on this, and probably the best known company to date that's actually entered into the Martian beer market is actually Budweiser. Not sure if you saw this.
No.
I think it was 3 years ago or 2 years. I can't remember which year. Time flies. Budweiser announced at South by Southwest they wanted to be the first beer manufacturer on Mars. And they had this big press thing with celebrities there on stage and their chief scientists, etc. And of course, at the time, we thought it was a PR stunt. Yeah, they want to be the first beer manufacturer on Mars. However, they followed through on it with real experiments. They have sent 4 experiments up to the International Space Station, 4 barley experiments.
Nice.
And so, looking at how barley grows, how it germinates, etc., and they've really invested in this. And this is very important. It's not just because we want a beer, or I personally would want to use it to make whiskey, but that is a direct investment in agriculture and space. So I think well beyond whether we want to drink in space, which I personally do, but companies like Budweiser investing in this are also making a direct investment in technologies we need to invest in for sustainability. If we ever want to have those cities in space, we need to know if we can grow barley or other crops in all these environments.
And based on that conversation that we had early on, it really is a luxury. I think alcohol has always been a luxury because you are literally taking a month's worth of food for a human being and turning it into one night's entertainment for a couple of people. So, what are the sort of, based on the book that you wrote all about alcohol in space, what are the constraints that maybe we're going to be facing as we move into this future?
Well, of course, the constraints is the volume of crops you're growing. You're not going to, as you said earlier with the example that Andy Weir gave, it isn't a very efficient use of your crops, but very well that particularly on those long voyages, they're going to use a certain portion of these crops to make alcohol. This has been an example throughout history in extreme areas. Even in Biosphere 2, I mentioned in the book, after a while, they started looking at the crops they had and tried to make alcohol. Eventually, they made a banana wine. Apparently, it tastes like crap,
yep.
But it really was, they really enjoyed it because they really needed a drink. So this will start off slowly, and most of the early alcohol will actually be smuggled or shipped depending on, who's doing the shipping, but eventually over time, this will grow. And this is a good thing. If we can look towards a future with actual substantial amount of alcohol being manufactured in space, we know that there's a sustainable human presence in space, that they have actually succeeded in agriculture. And once again, the more the alcohol industry looks at this, it helps the whole picture.
So I guess the existence of alcohol is an indication that the agricultural system is running so efficiently that it is able to produce this very valuable resource as a thanks to the surplus.
It is. And once again, we also have, of course, and kind of shifted a little bit over. I mean, and we know for a fact, even though alcohol is officially prohibited in space right now, we know that it goes on. There are many, many stories, not just the Russians, the Americans as well. But it's done. I've never found any indication that anybody being inebriated in space. It's always done in such small amounts for special occasions. It served as a wonderful bonding experience or method for crews. New crew comes on board ISS. They have a little reception, have a little shot of cognac. Not vodka usually. It's almost always cognac.
Buzz Aldrin drank wine on the moon. I just wanted to throw that in there. He did.
Oh, there you go.
So there's been one confirmed. Very communion wine, a very tiny cup.
He did, and that the Webster Presbyterian Church in Texas still has that communion goblet, and they do a service every year. The moon's I forgot the official name, but honoring Buzz's drink on the moon.
That's awesome. So let's talk about some of the actual other complexities, like we talked about the perchlorates that we're going to be finding on Mars. How well will various crops grow in the Martian regolith?
Well, okay, I'll get to the perchlorate in a second. Now, there are plenty of experiments here on Earth growing in simulated Mars soil. Some of that simulant is better than other versions. Very little of it has really utilized perchlorate in it. And so this is where we really need to start testing things or testing the removal of it efficiently. Now, we do know of several ways of removing the perchlorate. Apparently, you can burn it off, wash it off, and there are microbes that'll eat it off.
Right. And it's a useful resource on its own. Like, you're going to want that chlorine anyway. So for other things.
Yeah, if you can extract it, it's, be interesting to see as they build up these processes, if they can find the right process to remove it from the soil that we're using crops or growing crops in, but actually can extract it as a resource. That would be the best of both worlds.
Yeah.
So, but early indications in simulated Mars soil is it'll grow, but no shock here. You need to add nutrients if it's actually going to grow beyond a certain level. Apparently, most of the tests, it'll start growing to a certain point, but then, it starts dying unless you add nutrients.
Right. So astronaut poop, for example.
Pretty much.
Yeah. I think I saw a study. They said that hops actually, like hops and barley did surprisingly well. Hops especially did quite well. And so you're like, okay, space beer is okay. I got a couple of questions here. One from Jay Brodeur. Are there strains of yeast that perform well in low or no gravity? So do you get something special from zero gravity yeast?
There hasn't been a lot. I mean, there have been some studies. I know there has been specific yeasts that have been tested in low Earth orbit. It's way back in since the early days of exploration, but beer yeast got sent up. It was in the early 90s or early to mid 90s. I can't remember the exact year. I actually was a graduate student in Colorado at the time. But that was just one of your standard, I can't remember off the top of my head, standard beer yeast, and it did very well. So I don't know if they have determined if there has been any real study comparing the various varieties of yeast, which one did best.
Yeah.
But I have seen that yeast do pretty well. There is some change in them in that environment, but when you bring them back to Earth, apparently they bounce back pretty quickly. Well, what that means to if you're trying to actually ferment something in space, I don't know, because we haven't gone that far, letting the yeast go generations in space and then try to ferment, something in space. So it's an interesting area which really hasn't been studied that much.
And then as a follow-up on that, what about fermentation in low or no gravity? I mean, one of the techniques that people who are making alcohol have to use is this idea of specific gravity. Like, they're kind of depending on the gravity of the Earth, aren't they?
They are. I mean, that's one of the big questions. Once again, there have been some experiments, but it's, there are big questions here with the gravity, how that affects the interplay, well, as it ferments with the CO2 and everything else. We know, like, it's a little bit different, but we know even with something like carbonated drinks, they react completely different because the gas doesn't flow upwards.
Yeah.
And so there are a lot of different, substances that are in 1G act differently in microgravity. So it is, I don't have a firm answer. And there are probably people who know more on the very specific science on the fermentation, because I didn't look at every particular case, but it was clear this is an area that needs a lot more study.
Yeah.
As well as things like, of course, how humans metabolize alcohol in space, because we haven't been able to do any studies. Even though we know people drink in space, it's all unofficial, so it's all anecdotal tales.
Right.
Anecdotally, we think we deal with it fine, but we don't know that for sure, or have any science behind that.
But almost certainly, as you say, it is something that has been experimented with, and we will find out soon enough. Chris, we're running out of time, but if people want to pick up your book, where can they find it?
Just go to Amazon and just look up Alcohol in Space. And they should be able to find it pretty quickly.
And if people want to support what you're doing with Explore Mars, what should they do?
They should go to exploremars.org. And of course, you can find out all about all of our events. We're doing a lot of online events like everybody else these days. And hopefully we'll be doing the Humans to Mars Summit live in Washington on August 31st and September 1st. Like everything, we'll wait and see if that's actually going to happen. But it's already been shifted once. It was going to happen in 2 weeks, but not happening in 2 weeks, but we'll see. But go to exploremars.org and, we'd love you to help us out or join, help us in various programs.
Great. Well, on both fronts, both sending humans to Mars and making sure that there's beer when they arrive, we appreciate your work in both of these areas. And please let us know when either one has been accomplished.
I shall. Well, thank you for having me on.
Thanks, Chris.
All right, thanks. Bye.
All right, let's move on to the news portion of the show. First, I would like to know where I put my list of stories. There it is. Okay. I would like to talk. David, you're on my screen. What do you got for us?
Yeah, interesting study out of the 51st Lunar Planetary Science Conference that actually didn't quite happen because of what's going on. Actually, it became a virtual conference. But there was some interesting stuff that was to come out about Pluto, and I wrote about this on Sky and Telescope. It was actually some interesting geological science that was to be revealed about how and I think it's fascinating how just from the brief glimpse we got from New Horizons in 2015, they can infer running models looking at what they call compressional and extensional features on Pluto, kind of like how it's actually its state today and what they see on the surface and around the large heart of Pluto, the Sputnik Planitia area, which is what we saw clearly because we only saw one hemisphere. They can infer from seeing those features kind of what the interior and the modeling of Pluto. It's interesting that Sputnik Planitia was actually a big impact, that we know that that area there was differentiated from the rest of the planet, or the rest of Pluto, if you want to call it a planet or not. But they don't see any, they see a lot of what they call no compressional features, but they see a lot of expansion features. And that seems to lead to the idea that Pluto might have had a hot start when it was early in its early formation, that there was more energy being put in from radioactive decay and these impacts that were coming in versus energy going out. And that leads credence to the idea that's really been kind of tantalizing, that there might be a subsurface ocean on Pluto. there. At least at one time, there could have been a subsurface ocean there.
And this idea, we're seeing these all over the place. We're seeing, obviously Europa, Enceladus, but this idea that, there could very well be, I'm just going to move you a little here, you're high up. This idea that many of these icy objects around the solar system, from Triton to Haumea to who knows, when they find Planet 9, that all of them have some subsurface ocean, that in fact that the vast majority of places where life can be in the solar system is.
That's what was fascinating. Talking to one of the researchers, he mentioned Haumea too, that he said, and it's interesting because it's just we don't know a lot about it. We know it has a couple satellites and it's really elongated, but just from its albedo and the rotational reflection, we haven't seen it up close. But there's a lot of evidence to suggest a lot of other KBOs out there got this kind of hot start formation too, and there's other models out there saying that. So of course Pluto, like I said, since we flew by, we only saw Sputnik Planitia. Pluto stays locked to its large moon Charon, so we only see that Sputnik Planitia area when we flew by. That stays always on the antipode from the large moon. If you were standing there on Sputnik Planitia, you would never see Pluto's large moon. It would never rise above the horizon because they're in that 6-day rotation that they stay locked.
Right. The two are both tidally locked to each other.
Yeah. But we never saw that close in Charon's facing side up close. We saw it from a ways away, from like 3 days out when New Horizons was coming in. We got a kind of but it's interesting. The second study I looked at that was being presented too, they know even from that kind of fuzzy look at that, they know when whatever hit Sputnik Planitia was about 400 kilometers across. Wow. So it's pretty big related to Pluto. Yeah, Pluto's smaller than
that's a dwarf planet all on its own.
Yeah. So they know, though, it probably rang it like a bell, and they know that those ripple areas you see on the opposite side from where the impact happened before Sputnik Planitia kind of settled into that antipodal side after the impact. They know that that also the best modeling they were saying, looking at that, the way everything settled out today is as if Pluto should have had a subsurface ocean. So it's really intriguing.
Yeah,
I think it's neat that, when we were all waiting going up to 2015 for New Horizons to fly by, my worst fear was that Pluto's just going to be another cratered rock that's not really that interesting. And it turned out it really was actually quite fascinating. I mean, there's geologic activity going on down there, and there's all these different formations, and there's something of an atmosphere, and there was a lot of fascinating things. So I was just glad as we didn't see another cratered rock. It's like, okay, not really that fascinating, which is what I expected.
Really? Yeah. No. I mean, I think, you're not kidding. I mean, we saw glaciers of nitrogen ice moving across the surface. Really tall mountains made of water ice. As you said, a thin atmosphere, clearly some kind of activity going on the surface of Pluto.
So for such a long duration, it took over a decade. Well, it took about not quite a decade to get out there. I think it was 2006 they launched from
it was Cape. Like just shy of 10 years, like 9 years and something.
And if you read Alan Stern's book on Chasing New Horizons, how long it took to advocate for the mission, and it was an on again, off again thing, as all missions are, that it really, and it was a brief flyby that we really got a lot of science in bang for our buck just for that. What really surprised me is we found no moons. I even asked Alan Stern about that. He's like, I was kind of surprised too, because Hubble found new moons while New Horizons was en route.
Yeah.
So, and every time we've flown by Jupiter and Saturn and Uranus and Neptune, we found new moons that are just too tiny. They're probably there, but for whatever reason, New Horizons didn't see any.
Well, Alan Stern is absolutely planning his next orbiter mission to Pluto, so we'll just wait for that to tell us.
They are planning to. I was talking to him a little bit about this. They are planning a third possible flyby. They're scouting right now for a third KBO.
That'd be great.
And they did an interesting parallax experiment with New Horizons, kind of just a gee whiz. It wasn't really much for new science, but since New Horizons is like 40 AU away, I haven't seen the results from this. It was this past week, but I did write about this, that they were using two nearby stars. One is Proxima Centauri, and the other one was a Wolf. I forget the designation, very nearby. They were going to use this long 40 AU baseline just as a proof of concept that they could do extremely long parallax measurement and they were calling for amateur astronomers. Yeah.
Yeah, I think we've got someone working on a story on that. I forget who is on the team, but
I wrote about it a few weeks ago. I'm
Yeah.
curious. I haven't seen the results, but it was just it was to be the largest parallax measurement
Yeah,
ever.
you can imagine, like, if you could send the Gaia spacecraft out to Pluto's orbit, I wonder what kinds of parallax. I guess you probably wouldn't want to have to wait that long for it to go all the way around the sun. But still, I mean, the farther out you can go, the more accurate a parallax measurement you could get as it goes around the sun and sees these stars from a different perspective.
And the nearby ones will actually show quite a large,
Yeah.
several arc-second shift versus what we see from
Quite amazing.
our 2 AU, 1 AU baseline here.
Yeah.
So.
Thank you, David. All right, Alex, what have you got for us?
The big news I think that caught my eye was this new mitigation strategies for the disruption that Starlink. So Starlink is viewers probably know that Starlink is this new constellation of satellites from SpaceX. The idea is that they will provide internet around the world, particularly to underserviced or locations that are not serviced at all by the internet. It's been about a year now that the astronomy community has really been sort of raising the alarm about the impact that Starlink can have. So right now there's almost 1,600 of these satellites. That's a huge number of satellites already. They're planning something like 12,000. I've even seen 42,000 of these satellites. And you've seen probably these amateur images that people have been taking of these string of pearls, these satellites crossing over. Huge disruption. I think there's really two issues here: disruption to professional observational astronomy, as well as kind of polluting the night sky for people just looking up and suddenly seeing more satellites than stars. So I think the good news is that SpaceX seems to be really taking this seriously, and they came out with in their last launch, I think, DarkSat.
Mm-hmm.
They tried to reduce the reflectivity of this satellite by painting it black, essentially. That's sort of problematic in the sense that even if you're sort of reducing its albedo in the optical, it ends up absorbing more heat and starts glowing in the infrared. So their new strategy is what they're calling a sun visor. And basically, they're just going to try to cover up these white antennas that broadcast the internet. Of course, it's transparent to radio frequencies, which is how they broadcast the internet. But hopefully, it's going to sort of reduce the reflectivity. In the meantime, they're also kind of looking into how they can sort of reorient the spacecraft to sort of change the way that the solar arrays are facing us and also reduce the brightness. The goal is to get it down to 7th magnitude, and that is really at the limit of the human eye. So that's good on that one count as far as people looking up at the sky and not really seeing them anymore. You have to be in a really dark sky to see anything.
Yeah, you can't pretty much. The human eye can't go beyond, like, what, Dave? 5, 6 at the most?
6 at a dark magnitude site. Most places 4 or 5.
Yeah,
suburban.
Yeah. So 7 is great. I mean, that's a great target. They said that they've been working specifically with the folks at the Vera Rubin Observatory, formerly known as LSST. The concern there is that it's both a really sort of wide field of view as well as an extremely sensitive telescope. So you can disrupt these observations. And, sort of what I was reading is that once we start getting down to 7th magnitude, even though that is actually quite bright from a research grade telescope, we're, exoplanets, for example, we're looking at 14th, 15th magnitude stars.
There's nothing
LSST
that could mitigate that.
Right.
Yeah.
So, there's no getting around the fact that these are going to be, seen by these telescopes. But I was kind of reading up. Some people are saying once we get it down to 7th magnitude, we might have some sort of mitigation strategies on the observer's end to
I mean, I guess at that point, right,
things,
the goal is that you just need it to not oversaturate your detectors so that it's filling up not only the pixels that it's crossing, but it's starting to bleed into the pixels all around it and filling those up, and they're filling up, and you just lose a mountain of data. Because, I mean, astronomers are very familiar with the process of removing satellite trails from your photographs. Yeah, this is not new.
Right.
But but for the big professional astronomers, they're going to get one shot at some some event like a supernova or something. And what do you know? You got the star goes off, and you got this great big Starlink trail running right through your star, and then there go your observations.
That's right. Yeah. Particularly anything that's time sensitive. I had a Hubble observation that I performed a few years ago, and we had one shot at it. And if we had a lot of satellites coming through, that would have been a big problem. Now, another thing that SpaceX is saying is that they're going to be publishing in advance, really sort of where these satellites are going to be. It's a little unclear how accurate that can be, because my understanding anyway is that these have automated avoidance thrusters on them. You're throwing up such a big net of these spacecraft. They really kind of have to be autonomous in terms of course corrections. But the idea is that astronomers kind of look up ahead of time where these satellites are going to be and plan their observations accordingly. And just one final thing that I think is, like I say, a good thing about SpaceX doing this is that the reality is that this doesn't look like it's going to be the last such constellation of internet providers. There's others in the works, and so SpaceX is saying they're trying to get out of it and solve these problems now, so that other folks can avoid these problems.
The OneWeb constellation, they've already launched a couple, but they've gone bankrupt. As a direct result of the ongoing economic crash worldwide.
Shades of Iridium.
Yeah. I don't know if anybody bought them, because I noticed that their launches are still on the schedule. So I don't know if anybody bought the constellation or I haven't heard anything.
I mean, again, right, like we're in this situation where here we are in the middle of this crisis where everybody is having to work from home. And boy, wouldn't having high-speed internet to some of the more remote locations where people are going to have to work from their homes for the next 18 months to 2 years to some degree, wouldn't that be helpful?
Totally.
And then
I think we don't want to deprive people of these of internet access. It's a noble goal. And so, there's only so many roadblocks you can throw up before you kind of,
And I think that, again, to their credit, SpaceX has taken this seriously and has implemented features to try to mitigate some of the brightness. But at the same time, they're not asking the astronomers for permission. They are launching these satellites, and there's nothing that astronomers, it's not like they waited for the astronomers to approve it. So
exactly, and
feathers will remain ruffled, I think.
Right. Well, and the other sort of thing that's in line with the way SpaceX operates, but it's a little frustrating, is that they have this sort of iterative process of, we're going to throw it up there and see how it goes. So, when it was DarkSat, there was just one of, I think, 60 satellites that had this technology. And then the Sun Visor, same thing. I understand they don't want to throw 60 satellites up with this technology, but in the meantime, they're throwing a whole bunch of satellites up there that are not, not taking these mitigation steps. So, ideally.
And it might very well be that it's going to take a whole bunch of these, right? That it's going to take painting it black, also this sun visor. It might be that it's going to have to change its orientation depending on how much sunlight is reflecting, because there might very well be that for just a brief period of time, while it's in a very reflective point, it can just change its angle a bit, reduce its reflectivity even more, and then shift again when it's more directly overhead to other locations. So we should see, and they may even change the way these things look. And of course, over time, all this technology is going to speed up. We're going to see better technology in terms of solar panels. We're going to see better technology in terms of the way the transmitters happen. And then, of course, all of them are at most going to have a 5-year lifespan, because they are constantly being essentially sucked back down. They're constantly flying through the atmosphere of the wind, and without constant thrusting, they are going to re-enter the atmosphere and burn up. So,
right, and that's actually part of the reason why they're so bright, particularly after launch, is because of they're trying to mitigate that drag at these lower altitudes. They've got a different solar configuration that's trying to adjust for that drag, because otherwise they will fall out of orbit pretty quickly.
So you of anyone, you are a professional astronomer. You rely on the data, and I'm sure you're going to be gobbling up Vera Rubin data by the petabyte, trying to find perhaps a moon orbiting another planet. Where do you stand? I mean, obviously you're not going to speak for the entire astronomical community, but how do you feel about it right now?
Yeah, so I mean, LSST actually won't be great for my science, but it will be a fabulous observatory. I think I've said it on this podcast before. Internet for people around the world, especially places that are not connected right now. I think it's a really important goal, and so I don't want to stand in front of that. As long as we're taking the steps that we can take to mitigate these things. I don't think it's that big of a technological challenge to just reduce this magnitude a little bit, and we'll try to meet you halfway, hopefully.
Yeah.
I do what I can to encourage amateurs to get out there and say, whether you like Starlink or you hate it, just document what you're seeing. Go out and take a look and document what you're seeing.
Yeah, it's pretty amazing to see that the lights, the line of lights, the train as it moves overhead. I've seen one so far, and it's a pretty amazing sight to see.
We had a good pass here. I photographed Tuesday night. I almost wonder if there's going to be Starlink seasons, because it seems like in the UK last week, even from the older constellations, they were seeing them every night.
Well, you're going to get, I mean, obviously, as the nights get longer for the Northern Hemisphere, you're going to see them longer, the actual, like here in Canada, in the middle of August, middle of July, we see satellites passing directly overhead for their entire orbit, because
high latitudes for ISS passes, you can get like 4 or 5 in one night.
It's incredible.
It never goes into in the summertime. It never goes into the Earth's shadow.
Yeah, we'll have a time where we'll go out. You'll be sitting out there and you'll watch the space station fly overhead, and then 90 minutes later it flies over again, and you've been out there the whole time. Like, there it is, and then 90 minutes later, there it is again. Yeah, absolutely.
Amazing.
All right, thanks, Alex. Brian, what have you got for us?
So this was a interesting thing about how do you weigh the universe, and it's really more about finding the mass of the universe, because the universe is basically made up of energy and matter, and it's matter that has mass. And on a very simplistic level, the energy is basically dark energy that drives the expansion of the universe. Matter gravitationally attracts itself, so the matter of the universe kind of works against that. So finding out how much mass there is in the universe is central to understanding this, what we call a cosmic density parameter, which is basically that balance between matter and energy. And it tells us a whole bunch of things, not just about how the universe expands, but whether the universe, what's the shape of the universe, for example. Like right now, when we look at it, it seems to be flat, and it doesn't have some overall cosmic curvature. So this is one of those important things. And it's difficult to find out what all the mass in the universe is, because you not only have dark matter, which is already kind of invisible to optical light, but you have diffuse intergalactic matter and everything else. And how do you count everything? And so there's been lots of studies looking at how to do this. And one of the ways to do this is to look at actually the cosmic microwave background. Because basically you've got these two things in tension. And if you look at this kind of background thermal flow, it has little fluctuations. And the scale of those fluctuations, whether you have a larger fluctuation in temperature or a smaller, over a smaller range of the sky, a fluctuation in temperature, that tells you what the tension between those two things are. So you can look at the cosmic microwave background, and by looking at where the fluctuations kind of reach a maximum at different scales, you can say, oh, well, that means that there is a certain amount of matter in the universe. So the matter density is this. And so they've done this with Planck. So you look at the fluctuations of the Planck satellite data, and you get a value for how much matter, how much mass there is in the universe. Of course, you want to have other ways to do this. And another way is, to try and identify everything and figure out what the masses are. This new study looked at a statistical method. So it used a process of gravitational lensing. When you have really distant galaxies, as they come to us, they're going through all the matter or coming by some dense galaxy or something. And that means that the gravity of those chunks of matter are lensing the light that we see from really far away. So when you see an image of a galaxy that's billions and billions of light years away, it's distorted by the gravitational lensing of the matter as it reaches us. So we see a kind of distorted view of this galaxy because of all the gravitational lensing. Now, it would be nice if you could say, okay, this is the shape of the galaxy that we see. What is the actual shape of the galaxy? And then we could see how much lensing there is. And over a really large scale. So you can't do that for an individual galaxy, but you can do it statistically. So what this study did was they said, look, on average, we know statistically what the shapes of galaxies are. So if we look at what the shapes of galaxies we see, we know statistically how much galaxies are lensed,
right,
based on that statistics. So they use that and then a redshift measure to know how far away these galaxies are. Because if you have a certain amount of matter between you and that distant galaxy, if it's closer, you would expect less matter, even with the same density, than if it's farther away. So you know the distance, you know how much distortion there is, and you get this gravitationally lensed value of how much mass there is in the universe. Now, this is really great because it doesn't rely on something like the cosmic microwave background. What you're looking at is the distortion of the galaxies directly from matter. It's a direct kind of gravitational view of how much mass there is in the universe.
Yeah.
So that's great. Now, in this particular study, it got some headlines because the result that they got was shifted from Planck. So basically, if you look at the Planck study, it says this is how much matter there is in the universe.
Essentially, like for every cubic light year of space, this is how much stuff and dark energy and dark matter and energy there is in that cubic light year.
Right, on average.
On average.
Right, so you get the average density.
Yeah.
So the average density that you get from Planck is different from the average density that you get from this new study. It's called a kilodegree study. And so they're basically, if you look at the image of it, you've got like, here's the Planck data, and then here's this little kilo data, and they're shifted off. Mm-hmm. Okay. Now, in one sense, that's interesting. In another sense, I think the authors go a little bit too far in interpreting that. Because one of the things they do is they say, well, this study is off. Okay, that's true, but other studies are less off or actually in agreement. So when people do other direct measurements in different ways, not the specific statistical model, this is the one that is the most off compared to other studies. Yeah. So they said, well, that means that it's not really agreeing with the standard model of cosmology.
Right.
So what other models could possibly fit this? And they pointed out that one of them that would fit would be one in which the amount of dark energy in the universe changes over time. So basically you could say, well, there was a certain amount of dark energy back during the cosmic microwave background stage, really early in the universe. And then it changed by the time these galaxies were here.
Right.
And that's why you get a different value.
Right, which matches up with some of the observations that we had been talking about a year ago, and is interesting related to some of the new supernova, Type 1a supernova estimates as well, about perhaps the changing nature of the non-existence or the changing nature of dark energy, as opposed to being a constant.
So you're getting these kinds of things like that point to at least to the possibility that dark energy is not a uniform constant throughout all space and time. Okay, that's interesting. I don't think this study goes far enough to confirm that in any way.
Right.
But it is an interesting idea that we're finding these kinds of little things, because we're getting better data, we're getting new ways of finding things with this big data observations. We can find and test these ideas in new ways. So we're kind of in this stage where it's like everybody's kind of all over the map, and it's interesting, and somehow it's going to settle down to whatever the answer is.
But I mean, like on the one hand, you've got these observations from the Planck telescope, which are incredibly precise.
Yes.
And then like really nothing else holds a standard candle to it. And then you've got the Cepheid variable estimates, and you've got the supernova calculations, and you've got these dark matter lensing surveys and all this other stuff, and it's a lot fuzzier. Definitely, we've had this conversation many times now that their error bars in some cases do not overlap. Is it going to take gravitational waves to really get to the bottom of this?
It could. I mean, I think one of the things you have to be cautious about is that all of these studies are still in some ways model dependent. Even Planck makes certain assumptions that it fits into the model for the data. Now, those are based upon other observations that are also well validated, but it's kind of like the cosmic distance ladder, where you have a certain set of measurements with a certain set of uncertainties, and you take a set of assumptions there to go to the next level. So there's this chain of evidence which can be tweaked a little bit, but we're getting to the point where you can't tweak it anymore. Something's got to give.
Right.
And we're in the point now where we have all of these things where we kind of go, okay, something's got to give, but I don't know what.
Yeah, it's absolutely fascinating, and maybe this week has felt a little weird. I mean, probably 3 separate everything we knew about the universe is wrong press releases have come across the Universe Today desk, and I've mostly tried to foist them off on you and Paul Sutter.
I think that's a part of in these uncertain times, as we see.
The theorists are ruling the day.
I think it's that. I think a lot of press release folks are really desperate to get something above the noise. And so they're going to take the most unusual spin that they can. And I don't blame them, because these aren't kind of the normal situations. You got to go vastly over all of the noise that's there. Just to be heard. So I think these studies are interesting, but I certainly don't think that they are in this current time upending the cosmological models that we have. They're kind of poking at the edges and making us kind of re-examine some of this stuff.
Well, we're almost out of time, but I wanted to just share with everybody a pretty neat video that was released by NASA just today. Pictures from the Spitzer Space Telescope, and I just want to show you this before we actually wrap things up. Essentially, they found one of the largest black holes ever seen, with 18 billion times the mass of the sun. And what's amazing about this is that there is another black hole orbiting around it that's passing through the accretion disk, and it makes 2 passes in sort of over the course of, I think, like 12 years. And the Spitzer Space Telescope, one of the final observations from Spitzer was to capture the flares coming from these moments that the black hole passes through the accretion disk of this other black hole. Just, like an absolutely stunning accomplishment. When you just imagine the scenario that's going on there, it's just absolutely incredible. And
just to be clear, that's an artist impression.
Yeah, that wasn't the actual picture taken by Spitzer.
Were that a real picture, we would all be writing about it right now.
Yeah. No, the picture of Spitzer is a blob with another blob. But the point is that this was a discovery that they were able to make. And I just imagine the supermassive black hole that has 150 million times the mass of the sun. So not just like the one at the center of the Milky Way, but the one in Andromeda, 25 times the mass of our Milky Way, 30 times the mass of the Milky Way's black hole, orbiting around one with 18 billion times the mass of the sun. And those whole system is like 3.5 billion light years away. So just an incredible thing for us to be able to observe. And it just makes me sad that we have to say goodbye to Spitzer, because it's one of the most productive instruments in the field of astronomy, and the ending of another of the great observatories. All right, David, you are on my screen. Let us know what you're working on and where people can find out more.
Frequent contributor, Universe Today, Sky and Telescope. Here's the old book.
Look at that beautiful book.
Here is, I see it up in your background.
Yeah.
Here is the new book in its raw state, anyway. Backyard Astronomer's Field Guide to the Deep Sky.
Excellent.
Coming out, as far as I know, still July 21st, barring any shipping dispersal interruptions.
I can't wait to have you on as a guest of the Weekly Space Hangout again.
Also in the March Sky and Telescope, getting your scope through customs down there. My trip to Morocco became an article. So
yeah, that's amazing.
In there too, so
excellent. Yeah. And of course, you are Astro Guys with Zed on all the things.
Yes.
Alex, where can people find out more?
Follow me on Twitter, I would say. It's my name, @AlexTici.
And what are you working on?
Trying to finish my dissertation, man. Exomoons all the time, and trying to figure out how to get to my postdoc. I'm locked out of the country where I'm trying to go, so we'll figure it out.
Brian, what are you working on?
I'm working on an article for Universe Today tomorrow on physical constants and whether they change over time. You can find me on Twitter at Brian Coberline. You can find me on my website at briancoberline.com. And if you happen to see a seasonal Scientific American issue for this spring, there's a special edition, and you can find me in that too.
Wonderful. Cool. Congratulations. All right, so before we go, we just got some news that a couple of our friends in the science journalism field were let go from Wired. Wired, of course, has announced that they've cut loose a whole bunch of their freelancers, and we're actually seeing science journalists and just journalists in general getting axed across. Tens of thousands of jobs have been lost across the field. We're very fortunate with Universe Today because, we run such a tight ship. It's hard to kind of imagine us not being able to afford what we do. But absolutely.
It seems to me like sites are putting out a lot of content. I think it's as if all the writers are home right now.
Yeah. So the weird irony as the publisher, as the boss of two of the people in this call, traffic is as high as it ever is. If anything, it's higher, and revenue has dropped off a cliff, because all the advertisers have disappeared. And so the irony is there's lots and lots of people reading our stuff and nobody is able to pay for it. So just sort of thinking about, one, if anyone needs some very talented freelance writers out there, I know there's a lot of people that are looking for work, so please pick them up. They're very good. But the second thing is just have a thought. If you are consuming media right now directly, if there are websites out there, if there are publishers that you like, there are ways that you can contribute to their work directly through Patreon or through joining their service on YouTube or whatever, or follow them on Twitch as a streamer. Consider that even everybody is, in the science journalism side, everyone is working really hard to bring you this content, and there is no money right now, and it's going to be, as I know it's rough everywhere, but specifically is definitely rough in just news. And I think we're all depending on news, and especially good science reporting, to help us find our way out the other side of this epidemic. So if you have money to spare and there are science journalists and communicators that you appreciate, please take a moment and help support them. And even just $5 a month, $1 a month for whatever system or program they're using can go a long way. So, and I'm not just talking about me. Obviously, there are hundreds of thousands of great communicators out there that are worthy of your support. So just take a thought about how you can support, as many people as you can, especially the kind of reporting that you want to see more of in the world. All right. I'm going to bring everybody back on screen here. Thank you to everyone watching. Thanks everyone on YouTube and on Twitch. We know that you're all out there watching us there as well. Thanks to all the moderators and everybody bringing all the questions, everybody in the Weekly Space Hangout crew. We really appreciate your support. And thanks to my co-hosts for joining me once again and bringing the space news. It's always a pleasure, and we will see all of you next week. Thanks, everybody.